the Vietnamese.
When the first explorers came here, immersion in the Antarctic Ocean meant certain death. Now, with modern equipment, people can even play in these icy waters. These scientists are collecting information for the British Antarctic Survey in the South Orkneys. The old base here was first used as a whaling and sealing station. In winter, the only sealing is the ice. Scientists now overwinter regularly in the southern polar region. The Antarctic winter is beautiful, but it can be savage. On the base, the research team study the Antarctic ecosystem even during the coldest time of year. To study the frozen sea, they must first gain access to it. The temperature of the air varies with the weather. Even on a mild day, it's often 20 degrees below 0 centigrade. Underwater, it will be a steady minus 1.8 degrees. The neoprene wetsuits are extra thick, but otherwise, the equipment is much the same as scuba divers use anywhere else in the world. Getting to the dive site is somewhat different from elsewhere. The divers are highly trained experts, but under these conditions, a lifeline to connect them to the surface is an essential safety precaution. Underneath, all is calm, clear, and utterly magical. Although these waters are very cold, they are not lifeless. The undersurface of the ice is dotted with living creatures, some in suspended animation awaiting the spring, while others are active all year round. On the ocean floor, there are large clear areas swept by the scouring action of icebergs and sea ice moved by the tide. In the shelter of the rocks, algae can grow, and among the algae there's a rich fauna, highly adapted to life in this chill environment. The 12-legged sea spider is not really a spider at all, but a pycnogonid, a type of mite. Like so many creatures of cold climates, it's a giant of its kind. Most of the invertebrates down here are on the large side, and not surprisingly, few of them have common names. The isopod Antarcturus got its name because it is very similar to one found at the North Pole, called Arcturus. It lives by filtering particles from the sea, but in the clear water of winter, it finds food hard to come by. On the underside of a rock are the eggs of an Antarctic plunderfish. The adult is guarding them. Between the rocky bottom and the ice on the surface, the environment in winter is calm and sheltered. In gullies, where it's safe from the scouring effect of moving ice, lives the glippy. It's a giant isopod, an omnivorous scavenger which is found all over the Antarctic. It grows very slowly, with sudden bursts when food is plentiful, and it lives a long time. Studies of the adaptations of glippies are part of the biological research. Even with their modern equipment, the cold begins to get through to the divers after about 3/4 of an hour beneath the ice. The time has come to return to the surface. They transfer the specimens to a cool aquarium, some of them to be studied on the base, and some to be packed up and taken back to the survey's headquarters in Britain. Another part of the diving program is a form of fishing called trammel netting. Long, loose nets are laid along the bottom overnight to see what they will catch. When the net is in position, the crew tie off the ends and leave it alone for 24 hours. The net hangs like a curtain in the still water. This fish is sometimes called the Antarctic cod, though it is not related to the northern cod. But like cod, it is large and edible. Near South Georgia, its population was badly depleted by overfishing in the 1970s. This catch is to learn more about the species. Next day, the net can be pulled up. Research shows that the Antarctic cod grows and matures very slowly, so that it takes a long time to replace the part of its population removed by heavy fishing. The laboratories are equipped to deal with a wide range of scientific research. Some material is preserved to be sent back to Britain for further study, like the crystalline stones from the fish's inner ear, which can be used to discover exactly how old an individual is. By studying the sea in all its aspects, physical and chemical as well as biological, the scientists are putting together a picture of the Antarctic ecosystem, which shows that it is more complex than people had thought. It is also very vulnerable, because of the many interrelationships between the animals and plants. The temperature of the water is recorded regularly, and samples are collected for analysis in the lab. The recordings have revealed seasonal changes in the chemistry of the water, though its temperature remains fairly constant. Penguins and seals herald the return of spring in the Antarctic. They will have spent the winter in open water further north. Gentoo penguins are the fastest swimmers of their kind, but when they return in October to their breeding colonies on the island, they find the sea still frozen close to shore. They have to walk the rest of the way, which slows up their progress quite considerably. Young male elephant seals spar on the beaches, establishing their social status for a breeding season several years in the future. Elephant seals were among the Antarctic animals whose populations were hardest hit in the days of exploitation. Unlike the whales, whose bones still litter the beaches, elephant seals have recovered to something approaching their former numbers. Commercial sealing continued into the 1960s. The recovery of so many of the seal populations in less than 30 years is a testimony to the wealth of food available to them in these waters. Elephant seals feed mostly on fish. Chinstrap penguins eat mostly krill, which forms 2/3 of their diet. During the nesting season, each partner in a breeding pair takes it in turns to go to sea and feed. For the divers, a boat replaces the sledge when spring softens the landscape. They travel further south to explore the waters below the fragmenting shore ice. Gliding along the edge of an ice cliff, in water which retains the astonishing clarity of winter, the divers enter a world which is nevertheless breaking free of the bonds of ice. Eerie whistling and swooping calls, which they have heard underwater for some weeks now, are the Antarctic's answer to the song of British birds. They're the calls of Weddell seals, the harbingers of the Antarctic spring. A small swarm of krill has survived the winter, even though its usual food has disappeared. The little shrimps stay alive by grazing on tiny algae which live in the ice, themselves merely ticking over until spring returns. The singers of the curious noises, which sound like a shortwave radio, are a mother Weddell seal and her pup, which was born on the shore ice before it began to break up. The water remains relatively clear for as long as the ice subdues the surface. There's still time for a last look round at an astonishing world. When the winds of spring stir up the water, which will by then be unprotected by ice and clouded with swarms of plankton, these sights will be harder to see. A rich and complex assortment of underwater animals contributes to a scene whose fluid lines and warm colours are in complete contrast to the angular black, white and blue of the world above. Comb jellies, or stenophores, drift with the plankton. They get their name from their twinkling comb-like cilia. Penguins, these are Gen 2s, were classified as flightless birds before anyone had seen them underwater. But in their own element, they can fly as well as swallows. Beneath the ice, it's not the cold that takes your breath away.
Everything from customizing motorbikes to camper vans via Porsches,
Birds do it with effort or ease. Sugar gliders do it in a furry cloak. Even a few intrepid frogs do it, arms and legs flailing. Getting airborne is so advantageous to birds that it has dominated their evolution until every muscle and bone is dedicated to the mastery of the air. But a surprising number of other animals use the third dimension, even if only for a short time. On the grassy plains of Africa, several species of antelope, notably the impala, leap high in the air as they run. The leaps may be 3 meters high and as much as 10 meters long. One ingenious theory is that they do it to impress predators with their speed and agility, showing that there's really no point in trying to catch them. But impala leap when there's no predator about. It must have a purpose, but no one seems to know what it is. Nearby, a secretary bird is attacking a locust. Here, the value of taking to the air is very clear. The locust is so good at it that it's a wonder the secretary bird doesn't find some other prey which is easier to catch. Its long hind legs contain powerful muscles and a system of levers to fling the locust out of harm's way. It's a very successful strategy used by 17,000 different species of locusts, grasshoppers and crickets. The same principle, like an ejector seat from awkward situations, is used by tiny springtails found in damp places all over the world. When you're so small that a frog's eyebrow is a major geographical feature, it pays to be very quick and agile. Springtails are certainly that. The biggest of the world's 1,500 species of springtail is only 5 millimeters long. Most are much smaller. They're the prey of a wide range of carnivorous insects. They take to the air while the camera shutter is closed between two frames of film. In about a 50th of a second, they're gone. A water measurer finds them too quick to catch. Instead, it plunges its sucking mouthparts into a mosquito pupa, which has no means of escape. The slightest draught of air sends the springtail sliding on the surface film of the water. When they want to try a new location, they jump to it. On the seashore, taking to the air is a way of avoiding the attentions of birds like the turnstone. Flipping through the weed, it's looking for sandhoppers. Their instant reaction to being disturbed is to hop. They have no control of where they're going, and it doesn't matter, so long as it's away. They're light enough to land anywhere, any way up, without damage. The turnstone has to grab them before they have time to take off, which is not very long. That's why its movements are so quick and jerky. This ejector seat strategy, simply getting away from something without having any choice of where you're going to, is ideal for tree-living animals. Tree frogs live on the shiny surface of leaves high in the canopy. They hang on by using pads on their toes, maintaining a grip in some very precarious places. The toe pads are covered in tiny ridges. When the air is forced out from between them, the pad acts like a sucker to hold the frog to the leaf. When it lets go, there's always another leaf below to break its fall. The gliding frog, which lives nearby, carries the strategy a stage further. It can't choose where it lands any more than the tree frogs, but it can delay its arrival. It has similar toe pads, but it has webbed feet as well, all 4 of them, not just the back feet like other frogs. The gliding frog uses them as parachutes. When it sees danger coming, it takes to the air. There are plenty of dangers for tree-living animals. Faced with the inexorable advance of a tree snake, a gecko has no defense. But it has an escape route. When that route comes to an end, there's nothing for it but to jump. Its toe pads give it a firm grip on whichever leaf it happens to land on. And if it slips, there's always another leaf underneath. Taking to the air needn't be such a chancy business. Some groups of animals have structures which can be modified to make quite effective wings. The flying lizard is one. Many lizards communicate with each other by raising a flap of skin under their throat, supported by cartilage. The flap is in the wrong place to help in the air, but the principle can be extended to other parts of the body. Extensions of the lizard's ribs support a large flap of skin along its sides, so that it can glide from tree to tree by stretching out its skinny wings. The skin is camouflaged to help it avoid predators. When all else fails, it can glide elegantly to safety. Climb and jump is a method of getting about that has been adopted by some mammals as well. This bizarre-looking creature is a flying lemur, or colugo, in Malaysia. As it runs up a palm tree, it looks as if it's draped in a blanket. But when it jumps, the blanket becomes a parachute. It has some control over its landings, tipping into a stalling position just before it hits the landing tree. Flying lemurs are the size of a cat. They eat only plant material, leaves and shoots mostly. But plantation owners dislike them because they also eat the flowers off coconut palms. They can ruin the crop, floating effortlessly from tree to tree. For all their skill, though, the flying lemurs can only fly downwards, except at the very end of their dive when they turn up slightly to land. There's only one group of mammals that can fly upwards, and in any other direction they choose. As night falls in the Mexican desert, the cactus flowers open to receive their nightly visitors. The flowers are pollinated by bats. The bats find them by sniffing the air for the delicate scent. Then they come in to feed on the nectar. In doing so, they collect pollen on their whiskers, transferring it from flower to flower. They eat the rest of it when they get home. A bat's wing is a great improvement on the flying lemur's blanket. The skin is supported by thin finger bones at the end of a long forearm. It continues along the side of the body to the tail to make a true wing with which the bat can fly with great precision. The best precision flyers are found among the insects. Dragonflies, aerial hunters, need to be able to fly very fast and accurately to catch their prey. They have two pairs of wings, their movements synchronized to enable the dragonfly to fly backwards as well as forwards, and even to hover in place. This female is laying eggs on plants just below the surface, a task that requires absolute accuracy in flight. In slow motion, the coordinated movements of the wings are very clear. A ladybird has nothing like the same precision. Instead, it flies with dogged determination. Seen in slow motion, its hind wings drive it along, while the rigid forewings act like those of an aircraft, providing lift from their curved surfaces. The true masters of flight are the birds. They probably evolved from a group of reptiles related to dinosaurs. Their scales became feathers, their bones became hollow to save weight. Some people say the world's first birds may have looked a bit like this. The hoatzin lives in the wet forests of Central America. It can fly little better than a domestic fowl, blundering clumsily from branch to branch. The hoatzin looks primitive, and indeed it has some features which were found in very ancient birds. The chick has claws on its wings, just like the earliest fossil birds. It uses them for climbing about in the branches near the nest. The claws can be moved by special muscles to grip the branch. The chick's feathers are very slow to develop because it doesn't need them. These are primitive features, but the adult's digestive system is very specialized. In spite of the chick's apparently ancestral behavior, like a climb and jump reptile, the hoatzin is probably a perfectly modern bird with a specialized lifestyle. Its flying ability is nothing like that of the real experts. The fulmar, which breeds on high cliffs and spends its life soaring over the open ocean, is a master of the air currents, hanging effortlessly in the breeze beside its nest. A griffon vulture, with a completely different type of wing, can also fly for hours without flapping, resting on rising thermals while it looks for other vultures which might have found prey. When it spots a feeding gathering, it loses height rapidly, avid for carrion. The mechanics of bird flight have been of enormous interest to humans for a very long time. Watching snow geese leap into flight gives some idea of the sheer power needed to take to the air. The grace of their level flight is largely due to the shape of their wings, the aerofoil section, which is mimicked by the wing of every aeroplane. The curved upper surface provides lift even when the bird is not flapping. Every aspect of a bird's body is specifically designed for flight. Starlings are all-purpose flyers, with no special adaptation to soaring or great speed. Their flight is typical of a huge number of birds. The bird's body does not drop in the air when it lifts its wings. This is because the aerofoil section of the inner part generates lift all the time. From on top, we can see that the bird folds its wings during the recovery stroke to reduce the downward force they would otherwise produce. An X-ray shows that flapping is far from a simple up and down movement. It's in and out as well. The ancients believed that humans could imitate these movements. So they could, but even if they fixed feathers to their arms, the muscles needed to produce enough power would have had to be attached to a breastbone sticking out over a meter from the chest. A very odd-looking angel. If angels in human form cannot exist, the nearest thing to an angel in the bird world must be the tropic bird. Its tail streamers have no function in flight. They're for display during the breeding season, but they make it a very elegant sight as it swoops over its nesting islands. On the same islands, frigid birds breed, the males displaying to attract females with their inflated throat pouches. In spite of their enormous size, with a 2-meter wingspan, frigates are acrobats among birds. They need to be, because they get a large part of their diet by robbing other birds on the wing. In this case, an inoffensive booby. In aircraft terms, a frigate could be called a fighter. If that were so, a pelican is a stately airliner, heavy and wide-bodied, but no less efficient for that. An African fish eagle is a dive bomber, snatching its food from the surface in one fell swoop. The adaptations of birds are legion. If the starling is all-purpose, the barn owl is all-specialist. Its feathers are fringed at the edges for silent flight, not so that the prey can't hear it coming, but so that the owl can hear its prey. In spite of those huge eyes, an owl hunts by sound, not sight. It could catch this mouse in total darkness by listening for the little noises it makes. The equipment birds use for taking to the air also works underwater. Goosanders are wonderful exponents of underwater flight, chasing and catching fish in their own element. A bird's flying equipment can be used for some pretty bizarre actions too. This is a florican in India, parachuting to attract a female to its territory. More like a butterfly than a parachutist, an African wider bird displays by trailing its heavy tail like a black flag. The female is a drab, sparrow-like bird sitting in the grass below. After the male has mated with her, he flutters off on another circuit of his breeding territory. Some birds have evolved beyond the need to fly. By developing speed and strength, ostriches in Africa and their parallels on other continents can grow larger and heavier than any other birds. The heaviest bird that can still fly is the Cory bustard, a relation of the florican, weighing in at nearly 15 kilograms. Taking off involves a Herculean effort. At the other end of the scale, tiny hummingbirds fly with the buoyancy of a bee, their wings whirring at up to 250 beats per second. The wing beats of an albatross could be counted in single figures per hour as it glides over the Antarctic Ocean. Albatrosses spend the whole year at sea, returning to land only to breed. After a year on the wing, landing has to be relearned. Tussock grass is less forgiving than water, if a flyer makes a small mistake in timing. Birds rarely come into direct competition with bats, the other masters of the air, but there is one place where they do, outside the great bat caves of Texas. Inside, the bats cluster on the walls, waiting for dusk. When the time comes, they pour out of the cave like smoke or a swarm of mosquitoes. In all this boiling mass, collisions are rare. The bats avoid each other in flight by their sheer skill and agility. As they stream off to their feeding grounds, a bird waits, silhouetted in the evening sky. It's a red-tailed hawk. Watching the swarm from above, the hawk chooses its moment to attack. This is in slow motion. It has to be. What follows is almost too quick to see in real time. After a couple of misses, the hawk takes a bat from the air with its talons. It's a long way from the hops of the humble springtail to such total mastery of the third dimension.